Okay, picking up where we left off last time, we were looking at the development of a new equation, which is in your equation sheet that you'll, of course, have for the test, the AP exam. And I will spare you the whole derivation. I'll just write the whole thing. It's a pretty simple equation, and it's pretty helpful. Delta G in this little symbol up here is pronounced naught, which just means standard conditions. And standard conditions is STP, actually, well, 25 degrees Celsius, 298 Kelvin, and 1 ATM. So we'll put that in there. And it's equal to delta H minus temperature times delta S. And both these guys, again, at standard temperature. But we can manipulate these around, but we'll talk in a second. So notice again, delta G, it doesn't really have a life of its own. What it measures is how spontaneous a reaction is in regards to delta H and delta S at some temperature. And so if we happen to be at 298 temperature, then this value is just defined, and we can see it in the back of the book. So now we have all three values that you can find in, I want to say it's Appendix D, I don't remember which one it is, but it's the one that's got the delta H values in there. And now we have all three. So if you look in the back of the book, you will see delta H values. You'll see delta S values, and you will also see delta G values for a variety of different substances. But we can change this around for delta G if we manipulate this temperature around. So these have their own defined values at 298. But we can look at how this changes, which would not be at standard conditions. I could erase that and say based upon some other temperature, not 298. So we'll see how this plays out eventually. So again, this is looking at spontaneity. And if we think about a enthalpy reaction, delta H, we would think about a reaction being spontaneous. And what kind of a value, positive or negative, would you think delta H would be spontaneous? And if I'm thinking about being spontaneous, we would think delta H would probably be negative. And if we want delta S now that we understand that to be spontaneous, we probably would want that to be positive. And if you look at how the math works out, anything that's positive, anything that's negative, this is always going to be negative over here because of this minus sign right there. So it's always going to work out that way. There's a couple of classic AP questions that you should expect on the exam. And let's set up a little table to see how you could decipher some of that. We'll put over here just, and again, this is in your book, but these are very classic questions. Delta H, delta S, and a therefore delta G, and an understanding if the reaction is spontaneous or not. So we'll give a couple of circumstances. We'll say, okay, delta H is going to be negative, and delta S is going to be positive. Given those conditions, if we look at our little equation up here, and we already kind of wrote it out for this first example, what would we expect delta H to be? Under every circumstance, delta G is going to be negative, and that's always. There's no way we can make it anything other than negative. So therefore, if I know this is negative, I know this is positive, that reaction is always going to be spontaneous. Let's change this up. We'll say delta H is positive. It's an endothermic reaction, not spontaneous. Delta S is minus, negative. So that is going to be something that's not spontaneous as well. And if we put these into our little equation up here at the top, that is going to give us a positive value every single time. So when is this potentially going to be spontaneous? Never. It will never be spontaneous under these conditions. If I know this, it's never going to be spontaneous. So what happens if we mix it up? And this is where it gets a little more clever. So, okay, I've got these two values here. How does this one lend to being spontaneous? Always. How does this lend itself to being spontaneous? Never. Okay. So mathematically, when is this going to be spontaneous? Well, I want this to work if I'm thinking about being spontaneous. If I want this to work and I want this to not interfere with this happening, I have sets of conditions. It may be positive, it may be negative, based upon this one here. So I want this to not interfere. I need it to be as small as possible. So under what set of circumstances can I make this as small as possible? Low temperatures. So under very low temperatures, relatively, this reaction will be spontaneous, negative. And then just the same kind of thinking, if this is working against a spontaneous reaction, positive, and this is working for spontaneity, I still have the same set of circumstances. Maybe it is, maybe it isn't, spontaneous, delta G. When is this going to be likely to occur? Well, positive means spontaneous, and if I want this to be the overriding factor, overriding delta H, I need the temperature to be high. And again, a relative number, there's no defined number, it just has to do with the numbers that go into delta H and delta S. So I need this to be a relatively high temperature. And you would have to look at the specific math conditions in which that would provide for a spontaneous reaction. Okay, let's switch over to our notes, the handouts. So I think we're going to take a look at number 55. All right, I got my notes ready. Looking at 55. For a process that occurs at a constant temperature, express the change in Gibbs free energy, delta G, in terms of changes in enthalpy and entropy of the system. Okay? Pretty much it's like, what's the equation? I can do that. Set it up. Gotta put a little more lead in here. Okay, delta G is equal to delta H minus T delta S. So it's just asking, what is the equation that makes this whole thing work? And looking at part B, for a certain process that occurs at a constant temperature and pressure, the value of delta G is positive. Delta G is positive. What does that mean? Well, I think it means the reaction is non-spontaneous. And again, it's non-spontaneous in the forward direction. If it's going to be positive, it's non-spontaneous in the forward direction. Let's look at part C. And we talked about this earlier. What is the relationship between delta G for a process and the rate at which it occurs? None. None. They're not related at all. So we'll simply state that. None. Spontaneity is not related to the rate of a reaction. They're both, they're separate from each other. They're independent of each other. Easy enough. Okay, let's see which one we're going to move on to next here. Actually, it kind of looks like this is a pretty good place to stop. So I will end this one and we'll start up on the 4th lecture.